Hello Internet and welcome to a new video. Today I want to have a very first look at Apache Spark here on machine learning, and we're gonna open the Databricks platform, the cluster platform, and we have a very first look at MLlib. So let's start right from the beginning. We have Apache Spark. And if you're familiar with Apache Spark, this is an engine for executing data engineering, data science, and machine learning. And a very specific part is on single node machines or on cloud clusters. And today, as I told you, I want to have a look here at the machine learning sector. So train machine learning algorithms on a laptop and use the same code to scale off on fault-tolerant clusters of thousands of machines. And this is Spark. So if we have a look now at the libraries, we see that MLlib machine learning is the thing of today. And we are in luck because with Spark 3.2 that was released on October 13th, 2021, we have a new version of Spark. You can see that it runs everywhere. And the machine learning algorithm, what we are interested in, what can we do, is summarized here. And you can see here that we have some classification tasks, some regression tasks, decision tree, random forest, some clustering with the k-means, some topic modeling. Already showed you some topic modeling using sentence embedding based on BERT models. Here, a somewhat simpler version with LDA, some pattern minings, then we have some feature transformation, some pipeline construction for machine learning, some what's very interesting, and especially within the Databricks Community Edition and the environment there, the model evaluation and hyperparameter tuning. Maybe this is the topic of another video. And then, of course, you have other utilities like PCA and summary statistics. So here we are. This is machine learning MLlib guide, and we directly switch over to the lib guide. And here we are. We are now here within Apache Spark 3.2, the newest version. And the first that we can see here, the announcement is now if we have the discussion about RDD-based or data frame-based, now here very clear statement, we have data-based API is now the primary API, and the RDD, the resilient distributed dataset-based API, is now in maintenance mode. So very simple, forget about RDD, we are now data frame-based. Dependencies. What is Spark ML? Yes, maybe for some definition, Spark ML is not an official name, but refer to the MLlib database API. And we will have directly a look that highlights, well, yeah, that's interesting, but I tell you something, let's jump into the Databricks platform. We have here the Databricks Community Edition. You can try it out free of charge. And if you enter communityclouddatabricks.com, you are greeted with this welcome screen. Now, what you see here on your left side, that you have two modes of operandi. Either you have a data science and data engineering path if you want, and then you have an optimized machine learning environment with all the different machine learning libraries already up and running, loaded for you. And since our topic today is on MLlib, let's switch over to machine learning. Now we are greeting here with notebook, create a Jupyter Notebook, some reference solution, and then some start guide. So get started with a tutorial on training and tuning machine learning models. And this is exactly what we are looking for. So let's go with the official model and have a look at Databricks. Now, the first thing we are interested to do is to start up a machine before we run a Jupyter Notebook. And you have to create a cluster. So very easily you have here on your left-hand side the data. the compute and the job. So at first we have to go to compute, and we have, well, no clusters up and running, of course, because we have not created any compute engine here. So let's create a cluster. Now here you're now your first interesting part. Which runtime do you choose? Now easy, because we just follow the official documentation of Databricks runtimes. So we have Databricks runtime for machine learning. That's what we are interested in. We have some Photon for SQL workloads that are optimized for SQL. We have some light version, and we have some versions that are no longer maintained. So Databricks runtime for machine learning. Blah, blah, blah. This is the guide. And then we have a tutorial notebook. And if you can expand here the notebook, you can have here a look at the different things. And if you want to copy your notebook, what is very nice, you just say copy link for import. And then you have it now, the link saved, that you can say now Databricks runtime for machine learning. So Databricks machine learning guide, we have the data preparation, we have some model training, of course. In runtime version 10, we have now the Delta Lake, the Delta tables, we have our notebooks. There's a very specific feature, auto machine learning, which is very nice on Databricks. We have our models, and then we have our production. There is, if you're interested, a beautiful overview here on the Databricks documentation side. You can train your models either manually or with auto machine learning. You can track your parameters and models using MLflow tracking. You can share your models with some model registry, everything that you are familiar with. You have some quick starts, some tutorials, some specific user guides. So whatever you're interested in, this is the way to go. So we know that now, if we go back to our cluster, that we will take advantage of the latest Spark version 3.2. And we see here, we have three options. We have runtime version 10 without machine learning, with machine learning. And then, of course, we have machine learning with a GPU. But as you can see here in our free community edition, this Spark version is incompatible with the driver and the worker node types that are pre-selected for our community edition. So we go with runtime 10 machine learning Spark 3.2. And we call our cluster, let's call it M3, whatever you prefer. We have the availability zone is auto. And we have one driver with 15 gigs of memory, 2 cores, and 1 DPU. And a DPU is a Databricks unit, is a unit of processing capability per hour. And this is also, if you want to upgrade your cluster for some paid versions, you will see that this is an interesting parameter. And if we're here, if you want to upgrade for more configuration options, you can have here the cluster, clone cluster, display cluster, whatever you want. So there's a beautiful documentation here. And if you upgrade your Databricks submission, you have 3 cloud, of course, Azure with Microsoft, AWS with Amazon, and of course, good old Google Cloud. Now to notice here, we have not only GPU-based chips, but also here we have the TPUs, the tensor processing units with AWS. Maybe it's interesting to tell you that they now also have dedicated chips. You do not have to run on the GPU. And if you're interested, I just found out here today, and it is November 1st, at MIT Technology Review, we have a sponsored article by Amazon Web Services, where they tell you that now finally, they enable customer to accelerate their AI ML transformation. And now they're building high-performance, low-cost machine learning chips. And just make it a little bit better for you to read. And the first is AWS Inferentia, it is called. It's the first machine learning chip built from the ground up by AWS for the lowest cost machine learning inference in the cloud. And then they have another chip. This is AWS Trainium. It's a second machine learning chip by AWS that is purposeful built for training deep learning models. It will be available in late 2021. So also here, if we go back to our three major cloud cluster, we have here now also with Amazon dedicated chips, and you do not have to run it on a GPU. So, but back to our cluster, as you can see, it takes quite some time for the cluster to spin up. Our Databricks Runtime version 10 with machine learning libraries already loaded. So now that we have our compute, if you want to have some data, we need a cluster to create tables, of course. So we go back to our workspace and we say machine learning. Yeah, here we were. Let's click on the start guide. Let's take the official way. Now we spun up a cluster, so we say here's our cluster M3. This cluster we're gonna use, it is attached to the cluster, as you can see here on this little color wheel. It's not yet done, but we have now our compute resource online. Yeah, machine learning Quickstart, model training. So what we have our NumPy, we have our pandas, we have our scikit-learn, we have some optimization. This would be too early for right now. We run we upload our data. Of course, they are provided by the Databricks file system, Databricks dataset. Then we split in a training and in a test set, and then we just run a classification model. Here we use the machine learning flow tracking with autolog. We have some algorithm, our gradient boost algorithm I showed you in the machine learning libraries. We have train here our model with training data. We predict our model, and then we say, okay, the area under the curve, the AOC score, the higher the better, is calculated. And you can train it with different hyperparameters. So everything you are familiar with. What is very nice, I think, is a visualization here. And we are still waiting for M3 to come up, our cluster to come up. Of course, it's a free of charge cluster, so we have the lowest priority at all. You can have a look at the different performance models. You can load your models, and you have done some hyperparameter tuning, parallel training with something, the best models. But what is really nice, the different run, you have a visualization of your learning rate, your estimators, the specific characteristics you are looking for, and you can see which model performs best with which parameter, with type of parameter, and so on. So you can judge whatever you need. This is a very nice visualization. So this is it. It's all available for you to download. I would like to run through with you, but currently we're just waiting for the cluster to spin up, so I suppose I will be back with you in a second. So finally, our cluster is up and running, so we just detach and reattach the cluster. Here we go. So let's run through this demonstration. The code provided by Databricks. So we import our NumPy, our pandas, our scikit-learn, our dataset, our optimization. Come on. Yeah, it's a free version, so it takes quite some time. And then we go and we load our dataset directly from the Databricks dataset. Error, no such file or directory. This is not nice. This is not nice at all. Why is this happening? Just hold on a sec. So here we are again. The problem is that I get the error message that there's no such file or directory like the one that it's in the official documentation from Databricks. So what we do, since this is a Panda, what I found is just to make sure that it is available in the system. So we just have a look at the Databricks dataset. what data we have access to. Great. Show result, committing, running. Show result, thank you. Databricks dataset. Databricks datasets, yeah, we have here everything. There's the wine quality, what we are looking for, and then I just say yes. And show me the result. There we have our two files, wine quality -red and wine quality -white with the sizes, so files are non-empty. And then I just do, I read it as a Spark data frame. I don't know what's the current problem, but if you switch to Spark, I always found that this is great. Have a look at the Spark data frame. Do we have the data we are looking for? Yes. Acidity, sugar, chlorides, dioxide, pH, sulfate, alcohol quality. Looks good to me. What about our red wine file? Yes, also, so just what we have to do, we have to convert it back since it's a Spark data frame. We're running, of course, on PySpark. We are now converting it back to a pandas. And let's have a look if we are successful and we have a panda data frame with the data. Yeah, this is it, a panda data frame on white. And I suppose we have the same with red. And here we again, we have the red wine, now a panda data frame. So we go back to our code segment where we encountered some problem. We have now the white wine and the red wine as a panda data frame, so we can comment these two lines out. Let's see if we can run now the official code provided by Databricks. Yes, it is done. So now we have split our data set. We have our data labels. We have our quality perfect. Now I think, okay, now we activate MLflow. Beautiful autolog. And then we just say, okay, we have a model when we use a gradient boost as our MLlib, and we train our models. We have some prediction, and we have a look how good our model runs. And here we go. Okay, and the first is .88. It's not bad. You know, this is the area under the curve. One, I suppose, would be perfect. And if you're not happy with the performance, train another model. Let's do this too, since it is recommended as a training exercise. Let's see if we achieve a higher accuracy with our second run. Show the result. Oh God, come on. And now instead of .88, we'd get .89. Okay, so we can see our model is up and running. And to view the log training runs, click the experiment icon on the upper right corner of the notebook. Yes, 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 here it is. To display the experiment sidebar. Okay, let's click on this. Here we go. So we had two runs, the first one and the second one. Today is 2nd of November. Yes, Central European time. Yes, perfect. And at first we hit .88 and then the second run was .89. This is it. Okay. You can then click the experiment page icon to display in more detailed compare runs. You can click on the experiment page icon. This is this one. So what we get now? And here we are with. So this is now track machine learning training runs in an experiment. So we have the two runs. Took us a minute. Gradient boost. Model was scikit-learn. Our accuracy. Training accuracy, blah, blah, blah. So you can compare your models. This is very nice. You can download it whatsoever. You can also access the results of a specific run. Blah, 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 blah. You can also go for loading specific models. You can say now, okay, load my model from this specific run. Okay, let's do it. Okay, beautiful. This is done. And then you have some hyperparameter tuning. And there you have it. This is it for today. Databricks Machine Learning Quickstart. Some demonstration of the Databricks Machine Learning Platform, MLlib, running on Apache SPARK. And since we are here on a free machine, please, at the end of each session, do not forget, if you go to compute and you have your running cluster, because be kind to others who also are interested to use some free resources on Cloud Cluster. Delete your cluster, delete a cluster, terminates the cluster, and remove its configuration. Are you sure? Yes, please delete my cluster. Thank you for the free resources, Databricks. It was great. I had a very good first idea, first impression. Now clusters are gone. Data, we just had the data in our Jupyter Notebook. But if you're interested in your workspace, you can see here, you have here quite a lot of different notebooks, Jupyter notebooks that you can import. Just say import, and then you have some either the file or the URL where you have a Python notebook. You import your Python notebook, and it is within the cluster of Databricks. So this is it for today. Thank you for watching, and I see you next time in our brand new video.